This is Michael Resendez of group number 5 in EGN 4952C Engineering Design 2, and this is our group's final presentation video for our term project. In this video, the team and I are just going to be breaking down an overall summary of our project and the application that was developed on the Magic Leap platform. Additionally, we're just going to give a live demonstration of the application in action and then provide a brief discussion on the impact of our project and how we believe it applies to Tracer and fitness in general. If there are any questions at all during the presentation, all of the group's contact information is listed here, so just feel free to contact us with any comments or concerns. And with that being said, I think we're ready to jump right into the presentation. So here we can see a list of just the general project objectives that the team was given at the beginning of the term and the corresponding goals that the group set to fulfill these objectives. Okay, so at the beginning of the term, the Tracer gave the group essentially 3 objectives to accomplish. The first was to prove that the Magic Leap headset is capable of being an AV source for track and tracer technology. Essentially, what that's asking for is that current tracer technology operates via monitors and external sensor equipment. The group needed to prove that the Magic Leap headset is capable of being that AV source instead of a TV screen for their current technology. And essentially, the corresponding team goal the team made was, well, we're going to design a Magic Leap application that can simulate the functions of traditional tracer software and do it in an AR setting. Right? Objective number 2 was to show that the integration of Magic Leap has the ability to enhance the delivery of current simulations provided through a TV screen. So again, not only do we want to show that yes, these activities can be run on a Magic Leap headset, they can also be in some ways enhanced through the capabilities and hardware of the Magic Leap headset. So again, a corresponding team goal for that was, well, we wanted to implement physical activities on the Magic Leap application that could demonstrate the capabilities of an augmented reality medium that could utilize things like the Magic Leap's own spatial tracking hardware and its method of tracking distance and body movement, using the Magic Leap's own hardware for that instead of an external sensor equipment. And then lastly, the final objective was to prove that the Magic Leap augmented reality headset is capable of handling the Unity graphics that already exist on the track and tracer platform. And again, kind of like these previous two, it's just a proof of concept that yes, the Unity applications that are being developed right now on Tracer can be delivered on a Magic Leap headset in an AR setting. It is capable of handling those Unity graphics. So again, very simple corresponding team goal. We're going to build a Magic Leap app through the Unity game engine with C# backend scripting. And again, this should prove that the same environments, the same technology that Tracer is making right now for their current software can be delivered on a Magic Leap platform.
This is team member Siddiqui Brown, and I'll be talking about the project requirements for the next few slides. The project requirements are an outline for the major system requirements. More specifically, they are the goals or tasks that the system must accomplish in order to fully carry out its vision. For our project, we have 3 different types of requirements: functional, usability, and safety. A functional requirement defines a function of a system or its component. Usability requirements are documented expectations and specifications designed to ensure that a product is easy to use. And lastly, safety requirements identify protection requirements that ensure that system failures do not cause injury or worse to the user and prevent damage to any hardware being used. So we have 5 different functional requirements. First, the system shall provide exercises or activities for the user to participate in. Next, the system shall use hand tracking to detect when the user has touched the pillar. The third is the system shall keep track of user progress within activities. Number 4, the system shall calculate metrics like distance, velocity, etc. And lastly, the system shall log user data and send it to the database. Here under usability requirements, we have 2. The first being, the system shall not operate without recharging for 6 hours, and the second being, the system shall display the metrics obtained from the activity once the activity has been completed. And again, these requirements ensure that the product is easy to use. Under safety requirements, we have 3. The first is, the system shall require the user to confirm their play area before starting any activity. This ensures the safety of the user by making sure the area is clear and the user won't run into anything and possibly be injured. The second is the system shall be securely attached to the light pack, and the third is the system light pack shall be securely attached to the user's pocket or the harness while in use. Requirements 2 and 3 ensure that there will not be any damage to the hardware.
Hello, my name is Michael Vieta, and I will be discussing the project design of our presentation. So, the main thing that separates us from the Tracer applications and our project is the hardware. And specifically, we're working with the Magic Leap 1 headset, while the Tracer has their own device to be used for their applications. So, the main thing is the Magic Leap headset, which is an AR device, augmented reality. So that gives us that ability to make our application seem like imagery generated, over real world objects. So that would be the main thing. And now we can move on to the software. Okay, and then now we can talk about the software, which is another major part of our design. So we created two applications that were ports of Tracer's application, the first one being reaction testing and the second one being the flanker test. The reaction testing is the one picture on the top. It's the application that measures a user's response time. So the user basically would be able to hit in the middle where you see that red cube, and every time there's a green cube that pops up over one of the blue ones, you would hit it as fast as you can so it can measure your reaction time. And all this data would be logged into the server. And then the second test would be the flanker test. And this is one of Tracer's, original tests that they've created, called flanker. And as you can see on the bottom, it's basically like lateral movements. It measures like the distance covered by the user itself themselves, as far as velocity and also time difference while performing directional movement. So their purpose would be moving to the left or to the right to grab the cube, depending on where it's asking you to go. So that basically tests your velocity. So that would be it for the software portion. And the last portion of the project design would be the data handling. And we created a MySQL database, AWS, and this was how we were able to record all the activities that was being performed from our two applications that we built. This was good for us because we were able to perform, our own analysis and see how this could compare with, Tracer's data from their equipment. We had users of different ages and athletic abilities try out the headset, so this gave us a lot of data to work with.
To monitor the progress of our project's implementation of our team's design, we utilized Microsoft Teams and set goals for each member to complete. Development began by generating a virtual environment in Unity and to contain all the important UI elements for the user. One of the first things the team implemented was hand tracking. The Magic Leap system is capable of tracking hand gestures and spatial movement, and we use this to detect when the user has touched a game object. The main implementation change that the team made while designing our application was to the flanker activity, so that a user only has to move in a diagonal direction versus a lateral direction. We decided to make this change so that the user would not need to constantly be turning their head to correctly perform the activity. Not only did we think that constant turning would be taxing on a user, but we also discovered that the head turning can also disrupt some of the distance tracking features of our application. So we wanted to minimize this type of head movement as much as possible and demonstrate how the integration of the Magic Leap AR headset and the Tracer applications can improve the overall delivery and quality of the physical simulations. Magic Leap 1 applications use the Lumen OS and SDK for development. The Lumen OS provides C API function libraries that help to expose the interfaces to OS applications and platform features like 3D engines, integration, illustrations, and a collection of tools for software to help build and debug applications.
For project testing, we did two kinds of testing. First, which is testing the application using the hardware, and which is a Magic Leap headset. And the second one is by testing it with software, which is we use C#. The Dyna board is one of the two activities offered on the Teams Magic Leap application, where the activity looks to test a user peripheral vision by displaying a random sequence of cubes on the game board. The testing input should be the user pressing on the cube on the Dyna board, and the expected output is the reaction time that matches the time recorded by the external stopwatch, which it will verify that the headset is accurately tracking reaction times and it's providing the rational data for the database. The flanker activity is the second of the activities that we offered on the Teams Magic Leap application. The flanker activities looks to measure a user's physical movement and the body velocity by prompting them to move forward to grab one of the two the forward-facing cubes that appears in the game. In this testing, the input should be the distance it takes the user to move from the starting marker to the correct defined cube, and the time difference between the thumbs up gesture and the user grabbing the correct cube. The expected output is two sets of distance, time, velocity values. Another testing that we did is to ensure that the user can navigate the activities and menu in the application. Since the application runs in an AR setting, we decided to implement a system in which hand gesture. These gestures are meant to provide a user with intuitive way to move between menus and activities without a need to external controller. The purpose of the testing is to ensure that the user is taken to the correct sense to ensure that the user is taken to the correct scene after performing the corresponding gestures in the application. The other way of testing is using the software. After completing the activities and the data were collected, we gotta make sure that our AWS database is receiving data and they were uploaded to the team database. So we did script using C# and queries in MySQL to ensure that the database is working properly and it has multiple functions where it can insert data to database, read data, delete, and update from the script using queries.
This is group number 5 in EGN 4952C Engineering Design 2, and this is our live demonstration for our design project, okay? In the headset currently is team member Michael Vieta. He will be running the application. Also present is Siddiqui Brown, Ryan Foster, and myself, Michael Resendez, behind the camera. Abdul Zarli is currently quarantining right now, so he's not going to be able to be here, but we still think this is a great opportunity to showcase what we've accomplished these past few semesters and what our application entails. So Mike is wearing the headset. He is running the team application. He is going to confirm his play area with 2 thumbs up. Now he's just going to fill in a few demographic questions for us for our own analysis later with the team database. And then for the purpose of this video, we are only going to run the flanker activity just to showcase some of the features of that specific activity. So Mike confirms that selection, and now he's in the flanker activity. He's going to start it up by grabbing this cube. He's going to return to start, 2 thumbs up, and then he's going to follow the prompt that he is given. So again, just as a general overview, the Magic Leap 1 headset is using the flanker activity to track several important metrics for us. It is tracking the time difference between when Mike gives his thumbs up to when he grabs the correct cube. It is tracking the distance that he covers between those 2 points. And then it is using those values to determine other important performance metrics like velocity. And again, this is just our team's way of emulating the work that Tracer has done with the sensor equipment that they have. We're attempting to replicate that on the Magic Leap headset. And really, the team believes that this activity is a perfect example of the potential that Magic Leap and AR technology has for both Tracer and the fitness industry. So as we explained previously, current Tracer software has to be run with specific sensor equipment that has to be set up and tested, whereas this team's application can run an activity very similar to the traditional Tracer flanker test, but with just the Magic Leap 1 headset and almost any environment. And we think that's going to have a huge impact for both how Tracer software is delivered and how users experience it. So Mike just completed the flanker test. He's just looking at a brief report of some of his performance metrics from the activity, and now he's going to get out of the application, and we're going to connect his headset now to our computer over here, and it's going to allow us to upload his performance data to the team database. All right, so Siddiqui is plugging him in right here. We're going to use the Magic Leap the Lab device bridge to pull the SQL scripts that were generated by the application. We're going to pull those directly off of the headset to our computer, and then we are going to insert those scripts into this MySQL Workbench tool, and this is just going to allow us to manually insert this data to the AWS MySQL database. So that is what Siddiqui is doing here. And then he's just going to confirm that it was uploaded correctly. We're going to actually pull up the entire table, and we can see all the data that we've collected so far. And you can see that final entry. That was Mike Vieda's performance in the flanker activity. You can see, again, his demographic information. You can see the prompts he was given, the velocity that he had for each of those iterations, the time, distance, all those good metrics. So as the last part of this presentation, we're just going to give a general discussion on the design process the team went through, how we believe the team was able to accomplish a lot of the goals and objectives that it had set out through the last 2 semesters, and where we believe that Tracer and other interested parties can expand on the work the team has done so far. Okay, so again, this is just a list of project objectives that the team was given that we outlined earlier. I think the first important point to discuss is that I believe the team really did meet and accomplish a lot of these objectives and goals that were set for the team. Again, we were able to build a Magic Leap application through Unity that provided a physical activity and track data in a manner very similar to how Tracer does with their traditional sensor equipment and TV monitors. We were able to replicate that in the Magic Leap headset. And again, I think that really speaks to the true nature of this project was the proof of concept, proving that Tracer technology is applicable to the Magic Leap headset and an AR setting. And I believe the team, with the video we saw and the work that the team has done so far, we've proven that answer is yes, and that can be expanded upon. Another important thing, I think, is the team really expanded its knowledge on both Magic Leap, augmented reality, Unity, C#. I think a really interesting aspect is that many of the team members had never really worked on an AR project or worked in Unity or C#. I know for me personally, I'd never coded in C# before this project, and then I took on the roles as the C# script writer, and I had to learn quickly a lot of the tips and tricks for that. But I grew a lot more comfortable writing with that. Again, I wrote lots of code for it, and so I think in a lot of ways we've learned a lot about game engines development in that environment, maybe developing for augmented reality. So I think I think this project really did do a lot to expand our knowledge on aspects like that. Also, I think the team overcame a lot of challenges and learned how to be agile with project development. We encountered a lot of issues. We encountered a lot of bugs. Ideas we had that we thought would be applicable to the project ended up not being, and so we had to change course with that. A lot of the hallmarks of standard project development, delivering an application like this, we had to go through. But again, we held lots of meetings, we had general discussions, we were able to brainstorm and come up with ideas and really just overcome a lot of these challenges that we had. Okay. And then the final thing we want to talk about quickly is just that we believe there are actually still aspects and ideas that either this team or the Tracer team that takes over for this could expand upon in the future. Again, I think that their team only ported 2 activities. I think there were plenty of other Tracer activities that could have been implemented for this demonstration. We just happened to choose the flanker activity as the more traditional port. But again, I think there are other activities that could be ported to the Magic Leap headset, and I would encourage either, again, a future team or Tracer to explore that option. I think there are even more capabilities in terms of what an AR setting can do to enhance the delivery of current simulations. I think that our team really showcased, hand tracking, and spatial mapping, but really, I think even more so than that, you can create a lot more interactable objects in an AR setting that could really enhance users' experience with Tracer hardware. So again, I think these are just some of the ideas that, given more time, more effort, could really be expanded upon by Tracer. So once again, this has been group number 5 in EGN 4952C, Engineering Design 2, and thank you for watching.